Good afternoon, everyone, and welcome to today's Alpha Oak webinar. Thank you so much for joining us for part two of our conversation on SAP and GIS and utility operations. In part one, we opened up the bigger issue many utilities are facing right now. They have made major investments in both SAP and GIS, but the real challenge often appears in the space between them. That space is where asset data, network understanding, planning, work execution, field reality, and business accountability all have to come together. And when they do not come together well, the impact is not theoretical. It shows up in delayed work, uncleared ownership, duplicate effort, unreliable visibility, and transformation decisions that become harder to sustain over time. Today, we are going deeper into that conversation. We are joined by Martin Stenzik, founder and CEO of Alpha Oak, and Paul Marietta, SAP EM Solution Architect at Alpha Oak. Together, they will explore what utility leaders, enterprise architects, GIS teams, asset management teams, and field execution leaders should be thinking about when SAP and GIS are expected to support not just integration, but better operational outcomes. This session is not about treating SAP and GIS as two systems that simply need to be connected. It is about understanding how these systems need to work together to support the way utilities actually plan, manage, execute, and improve work across complex infrastructure environments. As always, we want this to feel like a real conversation. If questions come up as you listen, feel free to drop them in the comments or chat. We will do our best to address them towards the end. With that, I'm excited to welcome Martin and Paul and get us started. Martin, coming over.
Yeah, welcome to today's presentation, and thanks, Asha, for the nice introduction. When I look at this slide, let's start out with the conversation and why this conversation is so important. On the left-hand side on the screen, you see the reality most utilities still live with today. Traditionally, GIS and SAP implementations operate in silos, so they are very separated, siloed. You even have organizational structures that support that. Spatial data lives in Esri or in your other GIS systems. So we're talking geometry, network topology, in more sophisticated environments, connectivities, and the as-built digital twin, all maintained by the mapping organization. Work in progress layers, as-builts coming in from the field, could be digital, but also we have situations where it's still a paper copy. On the maintenance side, the financial and the maintenance data is owned by planners, managers, executed by technicians out in the field. Planners are responsible for larger subsets of asset maintenance. So we're talking about the master data, the technical objects, the maintenance plans, checklists, measurement points, for the SAP audience. That's sort of the bread and butter of what we're living with on a regular basis. The result is constant manual reconciliation between the two. SAP is usually working in their four walls, GIS is working in theirs, but the real business out there uses data from both systems. So reconciliation is real, data inconsistencies exist, but it delays decisions, misses opportunities, to really use the location information intelligently where it matters, most in sort of the capital planning work execution, and also regulatory compliance. One example being, a planner can spend 4 to 8 hours per week manually reconciling GIS as-builts with the SAP technical objects. Field crews discover incorrect functional locations or equipments on 15 to 20% of work orders, causing rework, compliance, additional drive time. We're showing up at the wrong place. All of those are examples of why this conversation matters. Now let's have a look on the right side, of the screen where the opportunity lies. We're not proposing another fragile interface, another, simple file extract import. that you have to run through a big error handling process. We're suggesting designing a modern governed integration where Esri's ArcGIS utility network remains the authoritative system of record for all spatial data, geometry, topology, and the live as-built digital twin. SAP S/4HANA, the EM functionality in S/4HANA, or the plant maintenance functionality, as you might be knowing it as, remains the authoritative system of record for the technical objects. So what that means is that even though you have an asset in GIS and the same or representative object in SAP, you're essentially getting to the point where one system will drive certain fields or certain attributes for the overall asset and is in charge of that. Whereas the other system might be the initial receiver of the asset, but ultimately being in charge of certain other fields and attributes. So it's going down not just on the record level, but really on the field level within that record to say who's the who has the authority to update and is the system of record for that particular field. All synchronization flows exclusively run through SAP's BTP. And one of the reasons for that is we want to make sure is that you don't need another infrastructure provider. So Esri and SAP can handle the end-to-end synchronization. But within BTP, we're using tools like Event Mesh, integration suite, and we'll come back to that a little bit later. We support three proven synchronization patterns. One is the real-time event-driven updates. That's what the business really needs and wants. Yeah, I don't want to have any delays between information hitting any of my business systems and then being spread across the business system landscape. So that's the first pattern. The second pattern is on-request bulk reconciliation. So the scenario being, I have my first rollout. I want to transfer a first set of large set of information from Esri into SAP. Those are the bulk pieces. And then we want to have the capability of an item by item granular synchronization or reconciliation of certain particular records to make sure is that if somebody found something that out of whatever reason is out of sync, we can easily reconcile the two systems without having to go through a major assessment activity and cleanup activity. This all results in higher data quality, faster capital and operational planning, stronger compliance, and significantly reducing certainly custom code, and gives you the clean core compliance on the SAP side that we're looking for, but also sort of the alignment with the well-formed architecture that Esri is promoting these days. So with that, let me hand it over to Paul to go on to the next slide.
Yeah, thank you, Martin. So let's talk about why, SAP and GIS alignment is more complex than it looks. At first glance, you may assume that the alignment between Esri and GIS and SAP is straightforward. You just, map your IDs and push your attributes. But in reality, the integration is significantly more complex. You've got two mature systems of record built on just a fundamental difference on a different framework. Esri is all about the spatial topology, where SAP is a hierarchical functional control and plant maintenance that's used to create notifications and work orders and all asset maintenance. So, the Esri ArcGIS utility network really excels at, spatial integration, topology validation, containment, and connectivity rules. And it's all about maintaining that asset out in the field, potentially under using, branch versioning, where you have inputs coming in from estimating and design and field changes, where plant maintenance is all about that purpose-built hierarchical asset structure. You've got class and characteristic management. You've got full lifecycle tracking and tight integration with finance and compliance controls. And so if you have a misalignment, you're really creating operational risk. You've got your broken hierarchies that are within the system, within SAP. On the Esri side, if you're not careful, you're going to have topology violations if you're trying to post data improperly without mapping looking at it. You run the risk of duplicate technical objects within SAP, which is a compliance nightmare. Same thing on the planning side. And if you don't do this properly, you're actually going to have invasive custom code, which threatens that SAP clean core on the SAP side. So, when we look at the architecture, we route everything through the SAP BTP, where we have those reliable events where the integration suite iFlows are used for mapping and sequencing, and yet establishing that strict governance of ownership. You have to be able to take these complexities head on in order for you to have an integration where it's sustainable, it's upgrade safe, and it drives value to your capital projects, your reactive work, your field operations. So when we look at the challenges that we have with the integration, there's two major buckets. And the first is editing and synchronization of the features and the technical objects. Typically, from a real world perspective, the mapping organization makes a significantly high volume of edits in Esri. They have to be validated before they hit SAP. At the same time, in SAP, we have hierarchical dependencies where we have to be able to properly create parent functional locations, child functional locations, child equipment, and sub-equipment underneath those flocks. And you need to have an intelligent orchestration where you have proper create and update logic. You're using global IDs to ensure uniqueness. You have proper sequencing, and you have the ability to conflict handle errors that occur within the interfaces as well. So if you don't have this, you're going to have duplicates and broken links amongst the interface or the two systems. And a lot of times this is invisible to one side of the business or the other. But in the end, it affects planning and technicians out in the field. So there are opportunities, and we have to be able to respect the high volume of records coming in. You have to have the ability to paginate large feature sets coming in, and that error reprocessing for thousands of daily changes coming in is extremely important. And that's why having that reliable architecture is important on the SAP BTP side. So with that, I'll hand it back to Martin to talk about the roles of each system.
Perfect, thank you. Yeah, so when we're looking at the role of each system, let's start on the left-hand side of the screen. You see here Esri's GIS system. For us, it owns the spatial world, geometry, topology, containment, and the live as-built digital twin. So the creation, edit, removal of the features in Esri is owned by mapping, but only key attribution is synced into Esri dataset from SAP to ensure proper coupling of each system. So we are not promoting anymore what we would have done 20 years ago, where we need to take large swaths of data and transfer them across the line. Today, we're promoting think of it almost like a minimal integration to say we need to know what asset in Esri is associated with what technical asset in SAP. And I'm stressing that because today we're talking a lot about AI and everybody talks about, yeah, we can do everything automatically. But in SAP, we have financial assets, we have technical assets, and technical assets are really not called technical assets. They're called functional locations and equipment. So you really need to understand the language, and the language becomes really important here to say, we know what needs to be mapped and synchronized with what object in the other system. On the right side, or in SAP, these days it's S/4HANA, the enterprise asset management functionality, or some of you might know it as a plant maintenance functionality, owns the enterprise asset management, specifically the work management side of things. Hierarchies, lifecycle events, a financial association, material associations, all of that is part of the enterprise, the SAP EEM stack. The integration shines because we can leverage the Esri data to manage large subsets of the technical object hierarchy, But there's a larger picture to see within S4 HANA. Asset planners have maintenance plans and items, measuring points, inspection checklist, all the things that you usually do not maintain in your Esri system is essentially provided and maintained and managed in SAP's S4 environment. In the center of it all, and to facilitate that integration, we're promoting SAP's business technology platform. As I mentioned earlier, we want to have the vendors fully locked in here. It's only Esri and only SAP that we need and we utilize to integrate these two systems. BTP is the right answer. It provides all the tools to enable all the integration patterns that we mentioned before. SAP requires obviously key information on the technical objects that are not typically maintained in Esri. So things like financial attributions, what are the cost center associations, potentially WBS assignments, settlement information, planning group, all of those have to be either automatically determined, defaulted, or assessed in some form or fashion to generate objects on the fly. But we can do that. We have done that for years. There are certain standard patterns for that. This clear delineation of responsibilities is what allows us to respect the native strength of both platforms, while delivering really the reliable, in large chunks, event-driven synchronization that is upgrade safe, clean core compliant, and aligns with Esri's well-formed architecture. So with that, let me hand it back to Paul.
Thanks, Martin. So let's talk about the data model behind the integration. So, on the left-hand side, you'll see here the Esri Arc GIS utility network, which is really the system of record for spatial truth. The utility network provides a rich set of asset groups and asset types for classification. The utility network also provides a well-defined definition of tiers and subnetworks for distribution, for transmission line mapping. It provides a full structure and domain network breakdown. There's powerful rules within Esri for containment and attachments and connectivity. And in the end, these are the elements that make the utility network a powerful model for utilities, for on the gas side, on the electric side, on the water end. With the SAP BTP, as Martin mentioned earlier, the standards-based mapping is defined in the BTP. And this is a layer that translates that richness on the utility network side into SAP without losing the fidelity or the granularity that's seen in Esri. So typically, and what we've done is the asset groups are mapped to technical object types in SAP, which are configured. Containment and attachment relationships are used to build the functionalization hierarchy. And what's key here is that the hierarchy is aligned with the ISO 14224 standard. Now, what do we mean by that? Well, your functionalization hierarchy by the standard should include definitions of industry, sub-industry, your plant and your site locations, your area locations, which we map on the utility network side as service territories. We have systems which map to subnetworks and transmission lines. We've got subsystems for the asset groups which include like pole locations where you may need to, or you will need to on the electric side, handle joint utility work activities. And then you have your equipment, which are mapped to features as well. And these are also, included with the equipment. You have your components as bill of material, tied to the equipment as construction types, and all of this is built into the interface. Now, what's important here is standardization. When you look at your data, you're wanting to get reliable analytics, whether you're doing failures or failure mode analysis. It's really important to talk the same language amongst each line of business, even amongst different utilities. And so this is where the utility network really provides value in mapping that into SAP. I can't, express how important the Esri Global ID serves as that primary key for bidirectional sync within the interfaces. We also have functionalizations and equipment and serial numbers, which are important. And then on the SAP side, it's the authoritative, well-structured master data definition of plant maintenance. In the end, we're going to have functional locations and equipment and sub-equipment. We have status profiles, which are mapped to the lifecycle management definitions in Esri. So the GIS statuses are taken into consideration and mapped properly over to ensure alignment between each system. So, it's not a loosely data copy that we're providing. It's really about that tight coupling where you get that precise hierarchical definition and the classification to run your enterprise maintenance processes. So when we look at processes, let's go ahead and shift. We'll move from the data model into real world processes for utilities. So when we look at asset intensive utilities, business processes is not, it's not just data. There are primary drivers of value when it comes to the process side. So when we look at utilities, we typically have 4 core processes, although it's not, these are not the only ones, but we have our capital projects. You have capital work that needs to be executed. We have reactive maintenance. We have emergency response activities. We have inspection and field feedback. I'd ask for folks that are watching, what to get feedback is where do you have, which of these processes do you have concerns around when it comes to reconciliation and your pain that you have in your organization today? So when we look at, capital projects, new assets are typically initiated from Esri. You have, it's the system of record for spatial geometry and network topology. Whether you're having, you leverage a graphic work design tool or you have a manual workflow, features are created and attributed in the utility network. And then once they're validated and posted, those events through webhooks are sent over to the BTP to create, to translate that data and then create the corresponding functional locations and equipment in SAP. On the SAP side, we can handle the project cost, the scheduling, the financial integration, and so on. And then, to call out for serialized assets on the capital projects, serialized equipment can get created on goods receipt with a subset of information from the manufacturers. And that's the proper process. And so the integration needs to be able to handle serialized assets where Esri still creates those features with its network connectivity, but then the serial number or the equipment ID, which could be the same because the serial number is an internal ID within SAP, is leveraged in the interface to sync up those assets without forcing duplication. On the emergency and the reactive side, SAP remains the system of record for notifications and work orders. That being said, after field execution, you have as-built updates that come in, and they come into Esri via redlining or direct edits. There's those validated changes are so important in Esri, and then that data is synced back to SAP. There could be, and there will be, a decommissioning of the old feature and a creation of a new object. Let's say you have a pole that's been replaced. What's important here is that we preserve the history and data integrity of SAP, which means that you create a new GUID, you decommission the old GUID, and you don't just leverage the old feature and equipment to just update that data. And this ensures that closed loop for accurate maintenance history, cost capture, regulatory compliance, and so on. So it's very important. Lastly is the inspection of field feedback. Again, this is coming in from Esri, and why it's so important is that that connectivity mapping needs to be able to establish that relationship in that's defined out in the field with the Esri data that's committed by the mapping team, and then that data is then synced back into SAP. So it's all about clear ownership of who owns the creation, the edit, and the field level, as Martin was talking about earlier. So in the end, we've got a closed loop system that is available for planners and field crews and maintenance teams to work on that, the authoritative system of record for asset maintenance, but still have that locational aware data, whether you're in ArcGIS, you're in SAP Fiori, you're on the mobile work order side for maybe SAP Service and Asset Manager. We're really trying to reduce the elimination and reconciliation effort that's needed between each system. All right, now when we look at, different utilities, we need to break this up by electric, gas, and water because Esri supports and has a utility network data model for each utility. So the architecture is deliberate when we have each utility. It's templatized, and you will need to be able to handle potential multi-utility frameworks. So sometimes utilities will both support electric and gas. And so what's important is that you have a standardization in the interface that can handle multiple utility networks within one SAP S4 HANA system. So, the integration will leverage that utility network model. But it also, there's two types of utility network models. There's the expanded and there's the essential versions. And what's important is that, and what we've done is we've used the expanded utility network models to build in the integration. So, what's key here is that we have consistent and repeatable mapping into plant maintenance, no matter what line of business. So on the electric side, there's huge benefits to the utility network, and we can leverage that on the SAP side. We have a concept of tiers. So there's generation, transmission, sub-transmission, distribution secondary tiers that we can leverage. There's terminals and device assemblies and complex containment definitions and substations. In the end, we can use this data to translate into a cleanly defined set of technical objects that are broken up by sub-utility. On the gas side, it's a little different. The tiers are defined using the utility pipeline data model, where you have system and pressure and isolation and cathodic protection. That being said, the gas side provides very strong linear asset support for pipelines using a combination of the utility network plus the Esri linear referencing system. So when the linear referencing system is coupled with the utility network, we can use that information in SAP as well when we look at linear asset management. So in the end, the gas side is broken down by those four different tiers, and we can map those into the technical objects accordingly. Now, on the water side, we have it mapped to the expanded models for water, the utility network. It's also the tiers are defined as the system and pressure and isolation and district meter areas and cathodic protection. But the utility network for water really excels around the connectivity for mains, service laterals, the valves, the hydrants. There's pressure zone definitions that we can map into technical objects, and we can also use boundaries as well in the boundary modeling to help to define where water treatment plants are at and so on. So we can use that all when we map into the technical object categories. In the end, we're mapping that right through the BTP. We use the, for example, SAP BTP Event Mesh. We use the integration suite iFlows. And we need to be able to have consistent group and technical object mapping, including multi-commodity utilities, as I mentioned earlier. And also what's important is that we in the functional hierarchy, I can't express how important that ISO 14224 is about standardization of the structure from the utility network. So, I'd ask that folks that are on the call, one is, are you currently using any type of form of hierarchical standards in your functional location structure? If not, highly recommend using 14224 as your guiding principles. Also, consistency on classification. What's really important in this integration is that we have consistency amongst asset classification when we look at the asset groups mapped to the SAP technical object types. It's always a major concern, right? How granular do you go with your technical object types? I'd like to get some feedback on, do you have concerns there? And that's where the utility model and our mapping can really shine here. All right, with that, I'm going to hand it back to Martin, and he'll take a look at the actual architecture.
Yeah, let's talk technical architecture. So this is a classic new looking architectural diagrams with all the SAP stencils in it. So what you see here is that this is what a mature best practice integration between Esri's ArcGIS environment and SAP S/4HANA looks like in 2026. We've deliberately moved away from fragile point-to-point interfaces and manual reconciliation activities. Instead, we've sort of put the subject matter expertise we have gathered over the past 20 years with the newly available capabilities that the business technology platform brings to us. But not just that, but also the underlying business systems. S4 now has an event functionality. Esri has an ever improving eventing functionality. So that gives us the infrastructure to put this architecture together. So looking at the diagram, what you find is obviously the two backend systems. On the one side, Esri's ArcGIS system, your geospatial platform with the necessary interfaces and infrastructure. On the other side, SAP S/4HANA, predominantly these days hosted in a RISE environment, but it's considered the on-premise solution or on-premise version of SAP. The good news though is that this interface can run exactly the same way against a public cloud version. Now there are other limitations in the public cloud that you might run into that lead you back to the on-premise version and standard RISE. But if you are a public cloud user, you could use this approach to interface your ArcGIS with SAP in exactly the same way. Because it's clean core compliant, because it's predominantly leaving all the functionalities in what Paul has mentioned before, iFlows in the integration suite, supplemented by CAP services. CAP stands for the Cloud Application Programming Model that we highly suggest you look into if you haven't yet. So that those two combined with the eventing functionalities that event brokers and the BTP bring to you are of the necessary ingredients to make this real. Yeah? There are other pieces like the Angular, obviously the identity services in order to have secure and authenticated information going back and forth. But all of this is essentially a well-formed integration architecture based on what we have available in our environment today. Coming back to the different integration patterns that we mentioned, event-based, on request, and then the item-by-item or reconciliation synchronization. Those are the three patterns you need to keep in mind when you're building something like this, and that's kind of what we're showing here. So let's move to the next slide. So what do we see as key takeaways? There are strategic outcomes and there are sort of architectural and operational wins. I would say that let's start with the strategic outcomes on the left-hand side, and then we'll ask Paul to join me here for this slide. But first, we're seeing sort of the true spatial digital twin feeding authoritative information into SAP EM process. That's sort of one outcome. So we're embracing the capabilities of the GIS system and the SAP system where they are at, taking that functionality and combining them almost to a point where you could say 1 + 1 is not equals 2, but 1 + 1 equals 3. So it really is getting amplified by getting these systems tightly integrated near real time. At the same time, we're having clear separation of ownership of who's owning what. So there's no ambiguity there. We know exactly what information comes from where and who is owning the audit trail, who is owning the result of that. We're completely respecting SAP's clean core and Esri's well-formed architecture and geospatial excellence information as far as the strategic outcomes. And then one more thing I want to point out here on the left-hand side that I think is becoming more and more important, and we're seeing it in discussions with our customers. How does AI fit into this? We believe AI is a huge benefit generator in general. Yeah. We, at the same time, though, do not think that these kinds of complex interfaces will magically sort of happen on button click and will be replaced by AI in a moment's notice. A simple example was the one that I mentioned earlier, where when you talk to SAP about assets, SAP will usually look at financial assets and not technical assets because they're called functional locations and equipments. So it's not as easy as just saying, okay, push button get banana. Let's just synchronize SAP assets with Esri assets, and then magic happens. We firmly believe that there's more to it, even if it's and the outcome of what we're doing and presenting here could be an MCP server that has an SAP to GIS translation service. But the underlying functionality still remains. You have to know the two sides. You have to do work in order to map this out. Can it be subsequently utilized by AI? Absolutely. But we don't think that AI is replacing these kinds of strategic and reliable interfaces anytime soon. Let me invite Paul back to the discussion. Paul, anything else you want to add to this?
This sounds good, Martin. Thank you. So, when we look at this integration, you have your strict separation of systems of record, but it's important that we have that, that integration traffic exclusively through the BTP. And what we're really looking for is that reusable, upgrade safe, templated solution where have complete asset synchronization that's really going to be supporting your processes, your capital projects, your reactive maintenance, your emergency response. We talked about the inspection feedback, and for all utilities, electric, gas, and water. So you're really looking for measurable outcomes in the integration. You're looking for higher data quality and spatial accuracy in Esri. You're looking for optimized capital planning and maintenance execution, faster locational awareness of where your assets are at, both from an operational standpoint, whether it's in planning or work execution on the field mobility side. You're also looking for stronger compliance and audit readiness. And in the end, you're looking for a significant lower long-term total cost of ownership to execute asset maintenance. So, this isn't just another interface. You're looking for a foundation for locational intelligence and asset maintenance, which is delivered as a governed and event-driven framework, both in Esri and SAP.
And I think that wraps us up. And I think to summarize one and to go back to one sentence, Paul, you just said is this is not just another interface. Take this serious. Whenever we are doing implementations in the utility space, this is one of the most important interfaces that there is. It needs to be reliable. It needs to be resilient. So it's not just a line item on your what we call in the SAP space the RICEVs, the interface, including the interfaces. This is a special one, and it should demand its own category. With that, let me thank all of you for listening. Thanks, Paul, for joining me in this call, and I hope you all have a good day.
Not just yet, but thank you, gentlemen, for joining us today. Give me 1 second. We want to make sure that we go into our questions. Hold on one moment. Hold on. We need to make sure we get Mr. Paul in here. Okay. Question number 1. For utilities that already have both SAP and GIS in place, where do you most often see the disconnect show up first? In the data, the process, or the ownership between teams? Who wants to take this one?
Well, I can start. Hopefully, it doesn't show up where we've been in the past, which is an incident where you have data between GIS and EL. We're sort of only about it in the context of something happened. Most often, so you want to do recording of information, the one that happens, it's the data ends and so on. What I now realize is null island. That's what people are calling it. So it's somewhere in the Atlantic at 0.00 data. So that's not what you want to have. Really, I mean, those are the two, I think, most obvious points. There might be others. Paul, do you want to add something?
Yeah, I think it's a tie between data and process. I think that there can be disconnects between the mapping organization from a data perspective that are caused by operational demand, including configuration updates and master data modifications, like changes over time for main work centers and cost centers, and WBS element mapping for settlement. And if you're not careful, you can have disconnects between each system. So you have to keep that communication open for changes that are there. Secondly, I feel like they're out in the field when it comes in from an operational perspective. We look at are we integrating the two systems together? But in the end, they're used out in the field. So is there any type of physical identifiers for technicians out in the field, integrated with SAP, so that the business understands, what asset that they're working on out in the field? And if it's very common for poles and transformers on the bank side to have a disconnect between what's out in the field, what's in SAP and in GIS, which can cause compliance and safety concerns, and it's a risk to the utility. So that's on the data and process side. And then lastly, on the process side, when these two systems are integrated, you run into what's the priority of operations versus the priority of mapping. Having that clear definition of which assets should be mapped first when it comes to the input into Esri, and have it come back down to SAP. So that's where we see a lot of disconnects showing up after you integrate the two systems.
Thank you for that, gentlemen. We have time for a couple more questions. For those of you that have questions watching this webinar on demand, feel free to DM us directly or check us out on our website, alphaoak.com, and contact us directly through the Contact Us form. Question number 2. When organizations talk about integrating SAP and GIS, they often focus on the technology connection. What should leaders be asking to make sure the integration actually improves field execution and not just system architecture? Who wants to take this one first? Rock, paper, scissors.
I think the purpose is the one that we want to look into. So in other words, the question I always ask these customers that you mentioned here, that customer group is, what do you want to achieve, and what do you want to get out of that integration of the two systems? The purposes we usually have organization of skills, making sure that when you're using it, you're driving the right education. It could be risk analysis, that your workers are based at the right point, so that your risk analysis does the right job. So there's a variety of. I think what we want to do is, we don't want to build or rebuild, as a matter of fact, interfaces over and over again for these different use cases, but we want to have one solid central interface that integrates assets as well as transactional data between these two systems, and then can serve all these purposes we've just mentioned. So look at it from a business perspective, not just from a it's nice to have. There's really a business case here to integrate these two systems, and the sooner you unlock what the benefit is, the better. Paul?
Yeah, I agree, Martin. On the business side, is there a reduction in the time to plan and execute work from a capital planning perspective, from a operations perspective, in a safe and reliable way? So, we look at planners. Do they have the right information to execute planning? Is the equipment available? Is it there? Are you making, talk about those assessments on the risk. Can you do that? Can you define what the priority is for the equipment on notifications? Do you understand where the location of that equipment is? And can you eliminate any type of input that's unnecessary by planning, like planner groups and plant sections and settlement attribution, which can be defaulted coming into technical objects, which could be handled by the integration. When we look at customer representatives, with new business work, when they're planning non-commodity infrastructure changes, do they have equipment addresses and historical work information based off location? Do they have all the equipment attribution to assist in that new business work activity? Do they have technician notes and planning notes? There's all this information that these teams need to do their work properly. Always like to, highlight the estimators and capital finance. Do they have the information that they need around, capital accounting activities, be able to execute design? Do they have the right taxonomy on the equipment to identify what the pipe sizes are, or the pool types and installation dates? And do they have joint utility agreements and so on? So it's really important to get that information in the hands of the estimaters and capital and finance teams. And then you can't forget the technicians. Do they have the right information to execute work out in the field? Do they have the right process in place to provide that feedback into GIS after they execute the work? So, these process and different user groups are really key when you start looking at how you integrate the two systems together.
Thank you for that. And last questions for today. What is one thing utility leaders should stop tolerating in the SAP and GIS relationship if they want better visibility, cleaner work execution, and fewer transformation surprises down the road? Do you want to start with this one, Martin?
Yeah, I think the idea is, where I think business leaders should get to, is that every asset in SAP has a geospatial representation. I think that sort of should be the tagline of every migration to S4, especially for geospatially diverse asset bases. Now, that's a mouthful, but what we mean with that is that if you don't have your assets within the four walls of a facility or a plant, at that point in time, and obviously in the utility space, we have lots of that. But even for generation stations or substations, more and more we're seeing the use of indoor GIS becoming popular. And within a substation, you might have big substations or the mapping down to a transformer and a substation where we want to have the geospatial location. So start with that. Every asset and every work order should have its own geospatial location as a starting point. And then you can peel back the onion whether or not it's necessary for every asset class. But that's where I would start. And that would be my ask to the business community to say, start asking for that, because there's, as Paul and I just elaborated on, there's so many benefits on the other side. But from the technology perspective, that's sort of what you should ask for.
Paul, do you want to add anything?
Yeah, I think I've got a few buckets. Few items. One is, a clear understanding of how the GIS features map to technical objects. So when we look at, the understanding of why is the technical object hierarchy developed the way that it is, right? How is maintenance planning and execution using that? The information that's defaulted into notifications and work orders. Why is this information and how is the information on the technical object hierarchy used in the asset maintenance process? I would say the next bucket of requirements, or that I would say that you need to ensure is embedded into the integration, is 100% delivery of information between each system. It seems, obvious, but there should be a clear and easy way to be able to manage errors if there are concerns. And then lastly, I would say on the technology side, a quick time to adapt to changes over time. Operations has a need to expand on the integration. There needs to be a very clear path for changes, that it's quick and safe, because this interface is used for operations and it's heavily relied on. Be able to make changes over time without risk or fear. That includes an upgrade, right? Having that architecture to get that clean upgrade strategy front and center. So.
Thank you, gentlemen. Paul, Martin, thank you very much for being a part of this webinar, part 2 session. I look forward to making many more webinars with you, making sure that we bring the education, the topics of discussion to our audience. Again, thanks for being here, and I'll see you all next time.